what we're going to talk about today, a few things. We'll talk about defining a performance, which may be a little bit trickier than you may think. We'll provide some practical approach to getting you performance you need from your application, and talk a little bit about the tools which can help you this way. Now, a lot of the focus in this presentation you'll see is about thought process more than specifics. For example, how exactly do I optimize this use case? Well, this is partly because of the time which was allocated, and also because I believe it's the most important to get your thought process, your methodology right. And then you can always go to Google and find the answer for specific problems, right? The more specific problem is, the easier it is to find the specific problem for that. And then go into kind of more kind of general approach questions. It's very kind of hard to get it just by Googling. You can check out the MySQL Performance Blog for specific advice from Percona. We write here a lot of our experiences with the customers, the problems we run into the field, as well as High Performance MySQL book also covers a lot of material. You can see it's quite heavy. So, when we talk about performance and performance definition, what do we really looking for from our systems? And then if
are these slides going to be available to us?
Yes, yeah, I will get the slides to meetup organizers, and then
So
if you have a technical ability to
post
publish
in the
them.
file section?
Yeah.
Okay, great, thanks.
Yes. So when we speak about performance, what I believe most of us want from an application, right? I believe we're speaking about application which is responsive to our users. We want it to be efficient, especially if we run it on Amazon cloud, right? Because it can get quite expensive, and we want to get it scalable. We don't want to run into a wall sometimes saying, oh my gosh, I'm getting those number of users doubling every week and I run into a wall, right? These, I think, are three criteria what we're thinking about when I speak about performance. And what is important in this case, all of those criteria, we need system just to be good enough for our use case, right? Not everybody needs to have a system built as scalable as Google or Facebook, right? In terms of efficiency, again, if you're just running, on the virtual hosted server and it works just fine, it doesn't really make sense for you to invest a lot of resources to make it 10 times more effective, to 10 times more efficient. And at the same time, with response time, right? As long as it's good enough and response in milliseconds, then your network latency will be much more prevailing factor to the overall response time, if there is no point of an optimized database. So this good enough is important because it's always possible to spend more time on the system to get more performance and make it better by all of those criteria. And it's very important where you know where to stop. Otherwise, you'll waste a lot of resources, waste a lot of money. The next thing which I believe is important is to focus on the application first, right? Look from the top level. Why? Because, well, it's really your database performance doesn't matter. It doesn't matter for your users and doesn't really matter from your boss in the end, right? We only care about our users, we care about applications. And database, as much as we may love it, only matters as much as it impacts performance of our application and user experience. Now, what is also so the database in the end is a tool what they use, right, to get our application going, and that is one of the problem areas which you have to investigate when we look at the overall performance problems. Now, when I look at MySQL, I try to keep two things in perspective. First, not all application performance problems come from a database, right? And that is very hard to understand for some people which have been very unlucky with the database. Many times you have somebody come to us and say, oh, I have a problem. Can you please take a look at our database? We ask him, why do you think that's a database? Well, because that's always a database. It was database yesterday, it was database the day before, right? So that must be database all the time. And sometimes, especially in the modern world, that may be something else, right? That's maybe just your Facebook API, which got kind of a little bit slower today, right? Or something else. Another important thing here, even if you discovered what the problem is with MySQL not working as quickly as you like, it doesn't always mean the problem has to be solved in MySQL. Maybe the answer is cached with Memcache. Maybe it's using Solr Sphinx or something for your full text search. Maybe it's offloading the data analytics in Hadoop, right? And MySQL is one of the tools which is available for you. It's great at some things, and there are some things which is not great at, and no matter how much Oracle makes it better, it's not going to be good for some things ever. Am I allowed to say that at this office?
Yeah.
Good. So, if you look at the practical approach here, what do you want to sum it up as well? You want to look at their complete system and look at the complete picture. Don't focus on the database, MySQL, right, in this case, tuning it alone. Now let's move on to the database and say what exactly do we do when we optimize database performance. I think a good way to think about that is to ask yourself what exactly database do. Well, database handle queries. That's all we do. So we throw our select, insert, updates, delete, and other kind of queries on a database, and we want database to respond to us quickly, right? That's very simple. We want it to respond to those queries quickly, right? The response time. That's understandable. We want that to be done also efficiently, going as to the question, right? We don't want to require a lot of resources for that quick response time. And we also want reliability. We want that to respond to the queries all the time, right? Not have some unpredictable response time going back and forth. And I think this last reliability stuff is often kind of forgotten by some people. When you speak about the queries, I think it's very important to ask yourself is if those are the right queries to begin with. In a lot of cases, you have to remember what the best way to optimize something is not to do it at all, right? If you can avoid certain queries or avoid fetching certain data from MySQL, that is a very great things you can do. Or you can also change how the application logic maps into the queries, right? Which is a very powerful optimization. Now, speaking about just set of queries alone, I would say I look at many applications, and that's very common when you would look at the web page, for example, and would go at the queries which it executes one by one. You'll find a lot of queries may not be needed for given user transaction to begin with. They come from maybe some legacy code, or they may be done just because of how the object's properties have been initialized and then they're getting unused. If you take that look at your application, you may find a lot of opportunities for optimizations. So how do we look at that? Well, you can take a look at your application transactions, evaluate which queries they are, where you need those queries, and wherever those queries are, the most efficient way to deliver what is possible, and then see how we can optimize those queries performance, right? Now let's assume what we have looked at our queries, and those queries are queries which should be there. How do we go ahead examining their performance? I think it's very important for us to look beyond their averages, right? In a lot of cases, we get those reports and say, in the average query executes X amount of milliseconds or seconds, right? Now, it's not good enough. In a lot of cases, what we find is what your most valuable users, maybe those who have a worst query response times, right? Your most valuable users may have the largest amount of data in your system, right, or something like that, which often results in much slower queries compared to the average. At the same time, you don't want to focus on the complete outliers. If you remember if you enable your slow query log and look at the worst case query response time for, let's say, a month, you will always find some bad queries. Because there is a lot of things going on, right? The styles could happen on the hardware level, on operating system level. And really, the MySQL and majority of the databases are not really hard real-time systems. They only expect you to deliver given query performance with a certain probability, not all the time. So what I like to look here is maybe look at the 95 or 99 percentile of response time to queries, right? To focus on my 99% of their queries kind of and ignore slowest 1%, right, or something like that. This usually gives very good idea. I also would encourage you to take a look at the trend of response time over time. Look for daily, weekly, sometimes monthly cycles, as well as the trends with the response with data size growth. When I speak about the daily cycles, the best examples could be people having a really horrible performance at 3 o'clock in the morning when a backup starts. Backup starts and the website essentially grinds to halt, right? Well, there are still users in some different time zone which may be suffering. If you assume your site or your system always performs the same way as it performs during your daytime, you may be wrong, right? In some cases, you may have some weekly activities or monthly, right? I remember some of the customers say, hey, wherever we start to do this, let's say payroll, our system kind of just starts to suffer very badly. It took them a while to align kind of those things happening at the same time because, hey, well, if things happen monthly, they're rare enough for us to think, oh, that's something exceptional, right? And by the time another month passes, we may have already forgotten what that was exactly a month ago, right? And so we can get really involved. So now let's talk about the tools which can help us to look at the queries and optimize them. And these are kind of some of the tools I are aware of. There's probably some others. PT Query Digest, that's a part of Percona toolkit, can look at the query performance statistics from either the query log or sniffing the network traffic. MySQL Enterprise Monitor has a lot of features based on performance schema, which is 5.6 plus, right, Dave?
Yeah.
Then if you're having this MySQL 5.6, you can also use performance schema, which if you're not looking for a fancy graphical user interface, you can also use this, their PS Helper tool, what Dave mentioned, to simplify their access to the data which performance schema creates. If you're looking for something more visual, you can compare it to Percona PT Query Digest. You can look at the box anemometer. This is their company box. One of the nice tools they have created for visualizing the data. Or you can also take a look at our solution Percona Cloud Tools, which is now in free beta, which allows you to analyze your queries graphically. So let me show you some examples for the software I use the most. This is PT Query Digest example, and in this case, it shows us this kind of lots of text, which is actually the server execution summary, right? It's a lot of text, but I think it's quite helpful to overview the server performance. What I usually look here is their information about the concurrency. Concurrency, you can think about that as a metric similar to the load average for your system, right? If the concurrency is high, that means in average, a lot of queries are running concurrently, and your load is relatively high, right? And you can think about that as very simple. If you if concurrency is low and your application is slow, maybe it's not MySQL. Maybe it's something else, because MySQL is not really overloaded with queries. Another thing which can be quite good to look at is this overall performance, right? So in this case, I can see what the maximum query time among all queries for a given period was 44 milliseconds, and the 95th percentile was less than a millisecond. So for this system, even without looking at the queries, I can judge what it's doing pretty well by most measures, right? 95th percentile of a queries less than 1 millisecond is probably quite good. Another thing what I tend to look at a lot is the relationship between those rows sent and rows examined, right? Because if your database is not optimized very well, what will often happen is to produce you a few rows of result set, it will scan through a lot of rows. For example, doing full table scan instead of doing indices, right? Again, it's not a guarantee, but that's a very good measure to take a look at. In this case, we are using a Percona server extension, which provides more information about the queries, such as, for example, we know how much I/O have those queries caused, right, and so on. So in this case, we can see for this period of time, we had only 6 InnoDB I/O operations have done. So this workload is completely in memory, right? The most useful thing in PT Query Digest. Yes.
Do you have a rule of thumb for rows examined and rows sent?
Well, so that's a good question. Now, the thing here is if a query is optimized well, right? Then if you're not doing any group bys, then rows examined should be essentially number of tables multiplied by row sent, right? So if I'm doing the join of 5 tables and it sends me in the end 100 rows in result, then I would expect it to examine 500 rows, right? Because of how it counts that. If it does a group by, it becomes more complicated, right? Of course, because it's very possible for me to group 1,000,000 of rows into one. Now, if your ratio is quite high, right, as happens in a group by, then you have to this is OLTP system rather than analytics. Then you should ask yourself a question if that's the right design, because if you're trying to group by 10 million of rows in a real time, right, that's not going to work, right? In this case, you have to think about that, right? And what I look at, I mentioned this example on the global basis, but what I like to do more is to look at that on per query basis, because in this case I can say, hey, this query is decision support query, right, or fact graph query. I don't really care whether it scans a lot of data, and this is my real-time query, which I don't want to scan a lot of rows, right?
So if you're not doing group by, really you should be looking at one-on-one.
Well, I mean, 1 to number of tables. I mean, 1 to 10 is probably a good idea, right? I would say for bad systems, probably would do 1 to 100, 1 to 1,000, right? And here's something else, right? Because if you think about that, if I have to scan one row, or if I have to scan, let's say, 10 rows, it's really approximately the same, because in this case, the overhead of parse and optimizer question is going to be a majority, right? So this is a case that's not a big deal. It's scanning tens of thousands or millions of rows. That's when you will really see the problems. Okay. Yes, well, let me remove this thing so it doesn't. Okay. Okay, so the next thing which is very valuable, I believe, is a profile which lists us the queries sorted by how much load they cause on the system. And you can see in this case what it's not the most frequent queries which can cause the majority of the load on the system, and not may not be even the slowest one, right? You can see that query number 1, for example, is very fast, right? With response time less than 1 millisecond, but it still responds for 10%. This allows us to really understand what queries you want to focus if you want to optimize system, especially in terms of efficiency. Finally, the third tool for PT Query Digest is the information on the query. If you look at that, it really looks very similar to what we saw about the server, right? That's query number 1. We can see it's getting a lot more efficient even, right? The number of rows examined, the number of rows sent is, in this case, almost the same, right? And there is no disk I/O happening at the same time. What you also would see in this tool for queries, which I value a lot, is a query response time distribution. In this case, we can see it's all the queries get response somewhere between 1 and 10 millisecond range, which is quite, and you see it's kind of very close together, which is normal. In some other cases, you may see something like what I would call like a camelback, right? You will have, let's say, 2 spikes, which may be happening because a query has 2 different execution plans which kind of flap. One of them is more efficient, one less, which you may need to work with. Or it could be having some of your queries are very fast because they are cached, and others are a lot slower because they go to disk, right? That also gives you the idea about opportunity for optimizations by getting more memory or using solid state drives.
So that's like a histogram you have there, is that right?
Yes, that's a histogram. I just well, that's how you draw a histogram, right? In ANSI art, right? In a sense. So now, if we talk about their Percona Cloud tools, we can see it would provide us with very similar information in reality in their in the web interface. You can, if you look at the previous graphs, you would see with essentially all their all the same data, and we can go and to see their information about their different queries in this case. Now, the graphical user interface, of course, allows us to make it more interactive. So we allow people to put some labels on queries, right? For example, some of the queries may be coming from your bad jobs. You want to label them as such, so you shouldn't really care what that bad job query takes 5 seconds, because nobody's waiting for that. You can also mark your queries like these queries, for example, marked as a need attention, or you can mark your queries like, hey, this is kind of reviewed like this. So this query has been reviewed by DBA and it's quite okay. So we can integrate, in this case, their reported functionality with some process how you can ensure to review your queries. This is an example of query details, which is again very similar to what you would see in a PT Query Digest. But what is important in this tool, of course, that gives you the information not just for a period of time you analyze logs for, but it tracks information over time. And that can be very helpful for you to really understand things. This is one of the queries what we see actually from the MySQL Performance Blog. And you can see what over time, right, we see 2 graphs here. First is the number of queries we have been doing per period of time, and the second one, how many seconds we have been doing overall, right? You will see very common to what you will see in a lot of applications. As the time goes, query becomes slow, right? It takes more time. Now, what you'll also see in this case, what it essentially drops down to almost zero. Well, what happened is really what somebody supported that query and then added a proper index for that, so it became a lot more efficient, right? So looking at that information through a period of time, you can understand how things develop with natural application lifetime, as well as any changes impact that. In this case, we speak about the index, but that could be anything. You could have an upgrade to the new MySQL version and observe how that impacted your query and any of your queries. You could have moved to a different hardware, or you could have changed your MySQL configuration options. I think that's ability to really have a history of how those changes you implemented impacted your different queries is very valuable, because the changes you may impact queries differently. For example, with MySQL 5.6, we often would see people finding some queries running a lot better than some others may get regression for one reason or another. So with this tool, we try, as I mentioned, we try to provide you support for the process, so you can discover the new queries in application, right? So it will report to you as a DBA what those queries are. Mark them as wherever they are fine, because you review them, adjust to select the primary key as you wanted, or if your query is something that needs attention for you to work with development team to resolve, and as well as toggle queries with application information and discuss their process for comments. Now, as I mentioned, what I think is very important here is what looking at the query performance is really giving us information about a lot of other changes we may see, right, in the application. Because what databases do in the end is serve queries. Any other change essentially is seen through a query performance in the end. Your workload changes, right? For example, you have users who started using your application differently, will show as a different query mix with probably different response time combination. Growth of a data size or some cardinality of a table relationship, that will also show as a query performance. Changing query plans, upgrading MySQL versions, changing MySQL settings, hardware, that all will be seen as query, as impacted response time queries. Okay. So, moving on from the tools, I also wanted to talk a bit about the efficiency, right? And we spoke again a few minutes ago about efficiency. Means essentially first we want to ensure we're having the right queries, and then we want those queries to be executed the most efficient way possible, right? So what kind of practical metrics you can look at, which can find you a lot of bad cases? How many rows are being scanned as or examined as sent? And we spoke about that already. How much I/O are we doing per query writing overall? Because if you're doing the I/O, there is a very easy opportunity for optimization, right? We know we can eliminate I/O by having more memory, or optimize by having a fast storage. Also think what if there is any avoidable overhead. Do we have any file sorts, right? File sorts, also known as sort on disks, maybe you can avoid that by either creating indexes or making that in memory. Temporary tables. Again, temporary tables are inevitable for some queries, but if you can make queries not to create temporary tables, and especially temporary tables on disk. That will do a lot for your performance. Now, as we talk about the queries, it's good to understand that there are multiple ways, multiple areas which impact your performance, and really each of them may have a lot of opportunities for you or may not. I would see that as a kind of your performance bound by your weakest link, and each of those you want to get essentially good enough for your application. It's very important to have a right architecture. It's also very important to have a right hardware for MySQL. And I think it's very important to understand what hardware those days can really go a long way. And you can get so much performance even from a single system. You can easily get a commodity server which would have like maybe 64 threads those days, more than half a terabyte of memory, and a lot more of a very fast flash storage. As Dave mentioned, you can be getting a MySQL which can run more than 500,000 of queries, simple queries a second. That is a huge number, right? If you think how that would translate how much user actions we can support, right? And at the same time, we can have a very kind of underpowered server scene sometimes, and people trying to say, how do I get my application optimized when we have a box of, let's say, some virtual box of 16 gigs of RAM, right? Or even like 1 gigabyte of RAM, right? Think about hardware, because that can be a lot cheaper than investing into, developer time or our services, right? Or whatever. Schema and queries. This is perhaps the largest opportunity, especially for efficiency standpoint, right? And I put them together because you really need to look at them together, right? If you just take your conceptual schema designed in academic wonderland, right, and try to put it in a real world, and then try to do the queries you like on it, that's probably will fail. It won't perform nearly well enough. When you design your schema, you want to understand what kind of activity, what kind of user interactions you really want to support, and design the schema to support that. That often will require a number of compromises, right? You may need to denormalize data sometimes, or double store the data, right, and redundantly to access that faster, and they have all kind of other decisions, right? But that will give you performance you want. MySQL version and a variant, right, those days as well, is also quite important. Though I would say in the recent years, we see the pace of performance advantages for common case have been reduced, just because a lot of low-hanging fruits have been already fixed by MySQL 5.5, right? When the MySQL 5.5 came out, I saw a lot of people just jump into MySQL 5.5 very, very quickly, just because we have had so bad performance problems with previous MySQL versions. Those days, I see a lot of less of that. For a lot of people, MySQL 5.5 works quite well and supports their application very well. That kind of is why probably the pace of upgrade to MySQL 5.6 is slower. But at the same time, for even certain edge cases of very high demanding workload, there is still a lot of room to improve both in MySQL 5.6 and MySQL 5.7. We're doing our part with Percona server, their MariaDB team also doing some very interesting changes, and I'm very glad to see there's kind of this different variants which keeps us all on the toes, right, and make sure we don't rest on our laurels, right? Finally, the MySQL configuration is also can be quite important. And by the way, I have produced the links with even presentation webinars which cover those topics in a lot more details, right? So when we speak about the MySQL configuration, well, it's important to note a couple of things, right? First, MySQL default configuration sucks. It sucks less with MySQL 5.6. There have been a lot of sensible default changes done. But still, if you have a half a terabyte of memory, right, and a fast storage, right, you don't want to put MySQL with defaults and hope it will work well. So you need to change some defaults, right? And for majority of application, it's just a handful of settings you need to get right. It's not a lot of changes, right? Don't be intimidated. There are something like 400 different settings available in MySQL. You don't need to change them all. You don't even need to know them all in most cases, right? And then this would cover 99% of the cases. I would say changing those handful of settings. Sometimes you'll find some very exceptional circumstances in which case you would go ahead and enable some other weird option which will give you another, 2 times boost. In most cases, you don't need to do those things. As a CEO, I cannot leave without a little subtle sales pitch. If you have MySQL problems, we're there to help. We do all kind of MySQL solutions you may need. And thank you.